Okay, today let's look at this problem. So essentially, what we need to do for this problem is that given a linked list, we want to group or we want to sew all the odd nodes together first and then connect the tail of all the odd nodes to all the even nodes. So for example, if we have a linked list like 1, 2, 3, 4, 5, then we're gonna group all the odd nodes first, which is 1, 3, 5, and then connect to all the even node 2, 4. So the relative order within odd nodes and within even node should remain the same. All right, so what is my thought process on that? Well, I think we can do something like this. So let's say we have a node like this. So this is a linked list with 4 nodes. What we can do is that we group all the odd nodes first. So we scan from the left to the right. And if it's a odd node, then we put the next field to the next odd node. And if it's an even node, then we put this next field to the next even node. And we repeatedly doing that until the end. So, and assume this is a, for example, an odd node. And we just need to set the next field of this last odd node back to the first even node. Okay, so that is the basic idea. And one thing we can do so for example, what is the yeah, I think the problem here is how do you write this while loop? How do you write this while loop to go from the left to the right and do what I've just said? All right. So we can try to write the main logic. So remember that odd node be the node that points to the current odd node. And that even node be the node that points to the current even node. So I'm only writing the main logic without worrying about the corner cases right now. So we can say while even node is not equal none, then we know that it has the next field. And even node dot next is not none, then we know that we can set that to in the next odd node. So odd node dot next is equal to even node dot next, and set the new odd node to be the even node dot next. Okay, now we'll do the same thing for the even node. And even node is equal to even node dot next. But and then we say, okay, the tail of the final odd node should be connected to the beginning of the even node, which should remain the same. Throughout this iteration, and then we can return head. Okay, so I don't have the corner case because we access the next field of the head. So if head is none, I'm going to simply return none. Otherwise, we can access the odd node as well as the even node. So now we have a few cases to determine whether our code is correct or wrong. So the first one is empty list, or a node with only one node, or a list with only two nodes, or a list with only three nodes, or a list with only four nodes. So if it's the first one, then we know head is equal to none, which return none, check. If it is the second case, where there's only one node in the list, we know that odd node will be the head and even node will be none. So even node will be none, so we never enter the while loop, and we'll simply set the head.next is equal to none, which is the same, check. But if there is two nodes in the list, then odd will point to the first element, even node will point to the second element, and even node is not none. However, even node.next, it is none because there's not a third element. So we never enter the while loop again, and we simply set odd node.next to be even node start, which is essentially the same array. So this is also correct. Okay, on test number 4, there's 3 numbers. So we're going to enter this while loop where we set on node.next is equal to even node.next. So we'll connect 1 to 3 and set on node to 3. And even node.next is equal to 3.next, which is none. So even node.next will be none, and then even node will also be none. So essentially, you have 1 connected to 3, and a 2 connected to none, and even node is none. So I'm going to say on node.next, so 3.next is equal to 2, and this also, and our code also worked for that case. Okay, for the fifth one, 1, 2, 3, 4, again, by following the logic of the while loop, 1 is connected to 3, 2 is connected to 4, And 3 will be the odd node when we exit the while loop. 4 will be the even node when we exit the while loop. So freedom x will be pointing to 2, so we'll get 1, 3, 2, 4. So again, check. Let's see. Yes,